All right. Well, thank you very much for joining. We just started this a more generic topic than we would usually do on a webinar. It would be more of an overview of data warehouses, lakes, and lake houses. But the way we kind of are positioning is this as well is to show a little bit of what we're doing at ClicData in terms of data storage and data architecture, because that may help you as well in future decisions. So this webinar is mostly focused around this type of what these things are, but we're going to bridge into a couple more examples and as well as how that actually is related to ClicData. But before I go too much further into this, just want to make sure that the audio and video is good. I'm hosting remotely. I'm actually not even in France or in the West or in Canada. I'm in Portugal. So of all things, not a very nice day here today, but nonetheless, I'm hosting remotely. I hope the audio is coming through fine and the video is going through fine as well. If not, please put up your hands and on your moderated chat. I believe it is moderated still. So yeah, with that in mind, audio video is awesome. I got some good feedback. So for those of you that do not know me, my name is Telmo Silva, and a good Portuguese name there, Silva. So part of the reason why I'm hosting from Portugal, I'm visiting my birthplace, and I lead ClicData as the CEO. I used to be the product and CTO. I actually went through all the different product designs, so I know the product quite well. But before that, and what entitles me a little bit, at least, to talk about data warehousing and data lakes is my experience previously doing this type of work for a variety of companies, mostly pharmaceutical and retail. So with that aside, also interesting, we're doing a multicast. I'm very excited about this webinar. It seems like we're broadcasting live on LinkedIn. So I'm not sure exactly how that affects things, but hopefully everybody can hear me here and via the LinkedIn event as well. Our agenda is very simple. It's to talk about data warehouses, data lakes, and lake houses. What are they, how, why, etc. And again, like I said, I'm going to touch a little bit about how ClicData is kind of adopting this technology, if you want to call it technology, or the framework, and how we're kind of progressing through data storage and data warehousing and analytics. So starting from the basics, and again, apologies if this is the stuff that you probably get from GPT or the web or Wikipedia, if you still use those old-fashioned methods of gathering knowledge and information. But data warehouses has been a long time. They've been here since probably even the 70s. I'm not sure if it's the 1980s, but basically it was that entire mindset of centralized data from different apps within the organization, trying to create data marts and creating star snowflake or star schemas that are easily normalized for the use of tools such as cubes and OLAPs and things like that, and then you'd put in your reporting and visualization on top. Data lakes kind of was this different strategy that came along as data kind of started growing, and basically everybody just started picking any type of format, but mostly file flat based format, because that allowed us just to keep appending data at the bottom and kind of continue the process. And that created a different type of analysis, and Hadoop and those type of technologies of basically saying, well, we're not going to deal with databases anymore. We're going to deal with files all over the place, and kind of we put them all in a big storage facility that can scale out quite nicely, and that doesn't have some of the implications of data warehouse. And then we're going to use different technology to try to read that data. And something more recent, potentially even sparked by I missed the name now, but it's going to come back, by some of the newer Databricks. Thank you. I could not remember. Databricks, I'm thanking myself, go figure. Databricks kind of probably coined this. I'm not sure exactly who coined it, but it's kind of this bridge between warehouse and lake. And the idea is that you still have these files, these high-speed files that arrive in these high-volume files, but that you still have some kind of a schema-based and structure that you can do analytics in a more standardized way. So we're going to talk about these. And at this point, I was told that I could send a questionnaire, but I'm not quite sure how to surveys. That's what they are. So question number one, hopefully that's the one. Question one. Okay, well, there you go. So this, I don't know if this is coming through to you guys, but if it is, great. If not, am I supposed to see some kind of okay, it's working. So basically, I'm trying to get a sense of the people that potentially use or don't use this. I'm not sure how many people we have actually on Click Meeting that can reply to this versus how many people we have on LinkedIn, but hopefully we'll get a good sense out of who's around. And okay, everybody's on warehouses, very few on. Oh, we got a couple of lake and lake houses. That's good. All right, so warehouses is clearly kind of the number one thing. All right, this is cool. Well, we try new technology all the time here. So now I'm going to go back to the presentation. I think if I can figure it out, how to go back to it. Not this one, not this one, this one. All right, all right. So yeah, I mean, like everybody, data warehouse is still kind of the big thing, and I think it's because it kind of fits our brain of organizing things before, kind of analyzing it. But here's a problem with data warehouses, and why actually data lakes and lake houses actually came through is, and this is not just a problem with data warehouses, it's a problem with data storage engines, is a question of choice. Is, data warehouses and transactional databases are very good at keeping transactions, but not doing analytics, or vice versa, right? So you buy a database for your financial system or for your website, e-commerce site, and it's very good at tracking transactions. And it makes sure that all the transactions going in the right order, that people are not modifying two records at the same time. It's got all these. We're going to talk about this asset stuff later, but it's very good at all that stuff, but it's very poor at aggregating things fast, or at least some are. And vice versa, things that are very good at analytics, they load stuff into memory and try to compress it and vertical store and all that stuff, but very terrible at transactions. Same way with structured data and versus unstructured data, right? If you have IoT devices that just feed data out, and they may have different schemas, this could be a problem for a very relational database. And vice versa, if you have a very struct schema and along the way you want to modify it, well, that poses problem. That creates reindexing and reschemas and all that stuff. And again, we talk about volume, and the reason why, potentially the main reason why data lakes came into play, is the high number of transactions. IoT is one of those, but across the board, visits to the website is not an Internet of Things, but it's voluminous, so people want to process those things faster. As well as larger companies, social media and things kind of sparked a lot of interest in that, because now they've centralized all these activities, which create a high frequency, high volume problem. Great for some databases, very poor for other types of databases or data engines. So trying to classify data storage engines now as a database or a data warehouse or as this or that is kind of difficult. There's a lot of technologies, not necessarily all competing. Some are kind of adopting. But going a little bit back in the history, if you think about how relational databases were in use, Oracle, PostgreSQL, I'm keeping kind of special databases out of this webinar for now, like Mongo and GraphDB and things like that. These are great databases for very great uses, but I'm kind of sticking with this the mainstream databases. So these were doing great for relational and transactional. They were the backbone of many, and still are, of many great applications. MySQL, of course, as a backbone of a lot of applications, including websites, pretty much almost all the websites around the world. But what these vendors start doing is to say, well, these guys are not really good for analytics, so what can we do? And what they've all done, in essence, is basically just try to parallelize the databases. So Exadata for Oracle, Amazon Redshift is a soup-to-nuts version of Postgre, a lot of modifications, a lot of hardware. By the way, all of these have not only a combination of software changes, but of hardware changes as well. So they've optimized the hardware to be able to handle larger volumes and solve those problems that we just discussed, and parallelism and multiple inline queries and all that stuff. There are some exceptions to this rule. Teradata and NetTisa, they were born directly as massive parallel data warehouses. They were made for data warehouses. They never had, they didn't take technology from Postgre or MySQL or any other known database engine. They were designed and developed straight as a MPP data warehouse. But very expensive. One is IBM, the other one I don't know who bought Teradata, but nonetheless, these are very expensive technologies, very specific hardware as well, and they're meant just for that purpose. Now, the mainstream is obviously moving things into Google BigQuery, which again, another modified version of an RDBMS, kind of scaled out, Google-sized. Amazon Redshift, great one as well. Snowflake, which is a combination of all those technologies in the sense their backbone is Amazon and Google and Azure as well. So a lot of kind of just trying to bring this old technology and kind of make it work for data warehousing, except, as I mentioned, a few of these. Basically, to understand the difference, the three different cases for warehouses, right? So obviously, data warehouse, financial reporting, compliance, sales and marketing performance dashboards. You can still do this for sub 100 million rows or potentially sub 10 million rows of tables of row size, and that works fine. It takes prep to do this, unless you use tools like ClicData and others that just define the schema as they go along. But you can create very solid data warehouses out of these. You don't need to go beyond that. You definitely don't have high volume and high frequency of data coming in through these systems. Potentially, again, depending on your industry, your sector, and so forth. But for the most part, a standard data warehouse can serve that purpose quite well. And and even if you scale that up, you have vendors that are there to help you with that in this massive multi-parallel way of things with Snowflake, BigQuery, Redshift, Azure Synapse, and so forth. And these guys can scale up quite high as well. Now, the data lakes is kind of born out of other needs, mostly IoT stuff, high volume frequency of transactions, like in banking industry or credit cards, those type of things. As I mentioned, web traffic. If you have a high volume use website, it generates a lot of visits, every page click, every page view, etc. So a lot of high volume. So there's data lakes are kind of made for that. And data lake vendors, here's kind of the ones that are the leading ones, or at least the ones that are making more noise out there. You got AWS S3, which is a stock. It's basically just a storage network, simple storage, right? You just put files in there, any kind of files. It doesn't have to be just text files. Azure Data Lake Storage, same thing. Google Cloud Storage, same thing. And then Cloudera as well. That's a great example of a data lake vendor. And finally, The Lakehouse, which is a great movie. And that brings me to the next, I'm going to forget about this. There we go. Question 2. Is this it? Did you like this movie? This is a great, Keanu Reeves is my favorite. So Sandra Bullock. I think they fell in love during the recording of Speed, if I remember this correctly. But again, great. Again, it's just a small joke. You don't have to vote for this if you don't want to. But I just thought it was a mildly funny joke. The Lake House. The Lake House is kind of, well, for lack of a better word, once again, the marketing brains at different companies come up with these, or maybe these are industry experts that like to sell more papers, and they come with Web 2.0 and big data. And Lakehouse was the obviously next thing, mixed warehouse with lake, and boom, you got Lakehouse. But what it is, it's really the same concept as lake, but you're kind of bringing the data in a little bit in a structured way already. And we're going to talk about this. So a lake house is when you definitely have a hybrid environment of data. You have very transactional based systems behind the scenes, which give you the data a specific way. And for that, it's kind of almost silly to now just flatten that data into flat files to put into a lake, into a data lake, right? And likewise, if you have files, you may not want to bring that into a schema-based relationship or data warehouse. So Lakehouse kind of does both jobs, where you have files which complement the data. Because if you remember, my first point is relational databases, which are the backbone of data warehouses, are not very good with volume data, and definitely not very good with volume data within the row. A lot of database technologies try to store binary large objects or binary large characters in their as a schema type, and that basically just blows the performance away. It's you now have a row with the scan of a PDF inside of it, as opposed to just a link to a PDF sitting elsewhere. And this is kind of the perfect kind of analogy for Lakehouse. Lakehouse is more of this example where you have a file sitting there with a scan of a patient, if you are in healthcare, or a PDF file, which now has a pointer to kind of a very structured table, which points to that file. But it goes beyond that, because what it also helps is with that flat file approach of just bulking in data really fast and kind of putting that into analytics right away without even going through the middle layer, which is this database engine, right? So imagine if you have a flat file, a delimited file with millions, billions of rows, and if you could read that file and create some sort of an aggregate and say, how many times does this happen, or what is the total of sales? And that engine uses the file to actually immediately calculate those analytics. That's really what the Lakehouse is meant to, which is the basis for lakes. So with that in mind, here's some data Lakehouse vendors. Databricks is definitely one that probably, like I said, I'm saying probably because I don't know, coined this Lakehouse concept first. Snowflake has that. Google Big Lake, Microsoft Fabric is their Lakehouse mode offers this. And it's interesting that they're a little bit more honest than the others were, and Snowflake as well, where they say Lakehouse mode, because in essence, it's really not something else. It's just a combination of the two other technologies, but nonetheless. So let's talk a little bit about more lake, because as the first survey kind of showed as well, it's the thing that we're least comfortable with. We're not quite sure what it is. How I know I wasn't when we were designing ClicData's approach to data lake and file-based analytics. It took us a long time to make sense of it, and I'd like to share that a bit later on. But let's kind of go back to the basis, which is, what kind of files are we talking about in this data lake? We know it's a storage. It's great for high volume, big files and big data, but what does that mean? Does that mean that I can put my Word documents in there and the movies and PDFs? Yes, of course. And those are accessible. And if you use some sort of machine learning or any type of OCR or things like that, or a parsing technology, you could extract information of those things. Email archives are also very good for that. That's what happens behind Exchange in many cases. But nonetheless, those are not really the ones I want to talk about today. I want to talk about the ones that are high volume, high frequency data, but in such a way that they're structured. They can be unstructured in the sense that one row can have different fields than the next row. Um, so kind of semi-structured data files, but they have contained plain readable data in the sense that if I'm able to open these files, I'll be able to see rows and rows and rows and rows and rows of data. So obviously, your CSVs, your delimited files, your flat files, fixed width text files, and JSON and XML, those are the classics, right? This day and age. Some are bigger than others, more verbose. Others pose different kind of problems. CSVs, we don't really know the format of each column. With JSON and XML, we can mark up the type, so we have a little bit more information. And then we got Avros and Orcs and Parquet, which is very, very kind of hot right now. Apache Parquet is a file format developed by the Apache org group, which is kind of an interesting thing. If you try to open it, you're not going to be able to read it. It's stored kind of it would be the same thing as opening a JPEG or a not a PDF, but PDF is still readable a little bit, but some binary APIs like movies and stuff, it's all garbage, right? But having the right reader, it actually transforms itself into a CSV in the sense. But what they did is they approached the concept of, okay, CSVs are great, but they're really, really heavy. So, we're going to figure out another format to store them in such a way that they're smaller and they're easier to aggregate. We'll talk about them in just a second. So I'm not going to talk about Excel, delimited, fixed width. You guys know all about these. You probably you have dealt with these all your life. This is parsing. You just have to figure out what the delimiter is or the width of the columns. You have to tell the parser what type of column it is. If it doesn't auto-detect based on some number of rows, etc., that's the usual thing. JSON and XML, you guys have seen this most likely as well. JSON very well used in web services, APIs these days. So they can have no markup whatsoever. So you need to figure out that first name is text, last name is text. XML is the same thing, but you can mark them up, or at least you can have some sort of a structure, a schema for your JSON and for your XML if you want to. So it is a little bit better. Mongo loves JSON. Mongo is JSON in a sense. That's how they really kind of work in a sense, right? And then, of course, we're going to get into these new files. So data files, Parquet, and the other ones, Avro, are kind of the same thing. Different technology, different approach of things, but it's the same concept. So the idea is, we have flat file data, we have row by row, we have row 101, Alice, etc. And we keep going. And instead of storing data row by row, so if I ask you what's row number 102, you have to go down the list. 102 is Bob, okay? They kind of pivoted things around and they store things by column. This is columnar vertical storing. And this has been kind of pioneered by a lot of databases. One called Vertica has it. One that is very well known back in the DOS days started using it. Unfortunately, I forgot the name. It was kind of a pioneer in that area. But in essence, a lot of these analytic formats are always in vertical format. And their reasoning is, and it has a very good solid base for that reason, is to say, well, if you want to do analytics with this type of data, then most likely there's going to be a lot of numbers and letters and kind of short amount. Okay, we're not doing machine learning with these. This is not descriptive content. This is not text that goes on and on and on. These are small columns with product IDs and product names and quantities and sales dollars and number of visits and all metrics and numbers. And these have a high compressibility, but also they have a high degree of repetition, right? If you think about, how many times does somebody buy, a car? You look by brand and you go, well, there's one sale here, one sale here, one sale here. Rarely people buy two cars on the same day or for the same customer in the same time, right? So 11111 is the number that keeps going on. Well, I can just, instead of writing 50,000 rows of that, I can just say 50,000 times one, and boom, that's my record. So this type of compression and this type of, which is used, by the way, in a lot of technologies, zipping and JZip and things like that. So this is what basically Parquet is. It's kind of a columnar storage of that row-based storage. And that saves a lot of space. And that you can load in memory and process really, really fast. So that's pretty cool. And this is what you store on your storage. If you go back to your Amazon S3 or your data lake, this is what you store. So now you have these type of formats, right? Columnar versus row-based. And they have different approaches. If you remember, this is actually not a lot different than our early database discussion between, Oracle versus Oracle with Exadata, etc. These are kind of improvements over transactional-based data. And I'll leave it up to you to this. I'm curious, actually, on this next questionnaire, how many people outside of CSVs and fixed files and JSONs, how many have actually used Parquet and Oracle? That one I'll actually wait a little bit longer. I hope that, I hope we're still on, that I didn't click anything. Question 3. Yeah, okay, so there's the new thing. So I'm actually curious to know how many people touch on Parquet and Oracle, or maybe another one that, maybe I don't have it for. And again, like I said, I'm avoiding specific. I know there's other type of files like EDI and multiple level kind of flat file. I'm not getting into those. Still sticking with kind of the main course. All right. So, as expected, and kind of our experience as well is most people are delimited and fixed width is definitely the biggest one. CSVs, Excels, etc. Parquet is just that's the lowest one. JSON, quite a few people. Not a lot of XML. I think XML is a dying breed, by the way. But yeah, so delimited is definitely the big one. Parquet kind of the second one. So that kind of makes sense. But nonetheless, maybe looking at Parquet could be something interesting for you. Just at least to be aware of it. I know this is kind of a lot to read, especially on a webinar. And I'll be transparent here. I built this half with looking at the web and half GPT, and I kind of added my own, fixed my own little things because I didn't quite like the answers, or that I didn't feel that it was actually correct. But in essence, I'm not trying to compare technologies saying one is better than the other. I think there's something here that is definitely good to know, that and that some of our customers are faced with right now, because that's the way they need to handle data. They are receiving flat files and not things such as nice queries and nice web services. Those things are good, but some of our customers deal with large batch sized millions, if not billions of rows. And for that, CSV hits its maximum. Doing things through direct connection hits its maximum. So Parquet files is a potential very good approach for them. So if you're looking for a way to transfer data via files using Parquet, and by the way, a lot of them still use FTP and things like that, which is quite interesting, then Parquet is something that could be interesting as well. Okay, and this will be shared later on. I don't want to go through this. It's not really the point of this webinar to give you something that you potentially can just get it off the web very easily, but you'll have this on the slides in the webinar in our website. I just wanted to talk about ACID, and I don't know how many people know about that, but I did mention there the reliability in ACID transactions. And this to me is kind of interesting because ACID really is kind of that ability to make sure that the data that you write into your data warehouse, in this case, or in your reporting system, is consistent. That it is isolated, that there's durability, etc. all the things that we're talking about here are things that happen on transactional databases, right? And a lot of people even use ACID to say, can I write a SQL statement against this, right? Can I write a SQL statement against a Parquet file? And by the way, until Lakehouses came about, that was not really a thing, right? SQL was not really related to data lakes in that sense, right? It was handled differently. So to me, what's more important is, can we reliably, as you receive Parquet files from your vendors, from your partners, as a way of adding to your data warehouse, your analytics, to whatever you want to do with that data, is it reliable enough? Is it going to make sure that it's only going to append or update the records that you want? Or do you have to reload the Parquet files again every time you have to do that from your storage location, right? These are all questions that are very important to answer when you set up a data pipeline, right? And you can't just say, well, yeah, send me by Parquet. Yeah, okay, but it's still a file, right? There's still keys on that file. There's potentially duplicates. There's potentially a lot of things that could go on in that file that need to be handled. So looking at a database storage technology that is ACID compliant is very important to make sure that the data is consistent, that it's durable, that it's isolated, and that it's at its lowest level, only committed or only entered into your database when you have the whole data set ready to go, and not just pieces, and then halfway through you don't have some pieces and you have to roll back and things like that. Okay, again, not the purpose of this, but it is important for you to consider that when it comes to lake houses, because until recently, like I said, lakes don't have that, and lake houses did not have that until somebody introduced this concept of kind of a delta lake. Yeah. If there's something about IT and technology that people love, is just coming up with crazy names, right? So we have lake houses, warehouses, data lakes, and now Delta Lakes, and I'm sure we'll have something else later. But basically, Delta Lake is really the approach to see how can we solve that problem of ensuring that the Parquet files, or the files that we receive. I keep saying Parquet, but again, it doesn't have to be Parquet. It's any file that's on your storage that the data lake ingests into your data warehouse, or that it treats, is going to be handled properly, and that it has the right data. So this Delta Lake is a new technology that is that adds this ACID check, if you will, or these requirements, prerequisites, at the schema, to enforce schema. But if you start reading this, you're going to go, well, Telmo, isn't this going back to just having the very issues that we didn't want, like enforcing schema? We wanted the freedom to put any file in there, and that the data warehouse just ingested, and that we don't have these slowdowns and locking mechanisms that usually go along with ensuring atomicity and things like that, right? So again, in the evolution of technology, there's always ups and downs, and you invent something better, and then, yeah, but it doesn't do this. You have to go back and improve it, and so forth. So Delta Lakes is kind of, the best technology of both. But again, you don't have to do that. It's just to know that, even that is being solved as we speak. Now, the bad news is that these were the basics. Now I'd like to kind of go a little bit beyond that. And I also want to talk about what ClicData has in store with this, right? Because I think it's important. Some of you may be ClicData customers. It's kind of, okay, what does that have to do with ClicData? Because ClicData, you have connectors. I connect my data. I see the tasks loading the data. I have a table of data. I can do data flows. I can do dashboards. I can do everything else. Where does Data Lake fit into this, right? So going to get into that for a second. So first of all, let's just talk about the basic of operations, which is of any data warehouse, of any data pipeline, the basics. The basics are, first you need to get to the data, load it, okay? It doesn't matter if this is a data lake or whether this is a data warehouse. You have to go get the data from somewhere. Somebody's giving that data to you somehow, and you need to put it somewhere accessible. The second piece is typically you need to transform it. You need to clean it, augment it, reduce it, joins, fusions, whatever you have to do with the data to make it suitable for analytics. Even if it's on the fly, you will have to do it. It's just something that is done on the fly, but it is a step during the analytics piece. And then, of course, there's the analytics piece, which is actually do the group buys and the aggregations and saying, okay, your sales are X. That's the sum of something. And also as well, machine learning. Anything that you want to do on this data, again, machine learning will apply on that. So those are the three basic blocks that you always have to do, right? So how does that differ from one to another? So, if you have these files, you can now do something like, well, I have somebody's giving me these type of files. I can kind of parse and load them one at a time into the data warehouse, right? A data lake and a data lakehouse, all you do is copy them. So there's no parsing, there's no logic at the point of loading. It's really simple. You just copy. If they were on FTP, you put them on Amazon S3 storage for using Amazon products. If you are on ClicData, you copy this to file storage, and the file is there. It's a file. It doesn't matter if it was a video file or if it's a Parquet or a CSV. It's on your file storage. That's your data lake. Okay. Data Lakehouse, like I said, it's an extension of Data Lake, so it's exactly the same thing. So that piece becomes very easy to do, right? Because now you're just copying files. All right. Loading from apps, not as easy, right? Because if you're using a cloud app, let's say you're using HubSpot or whatever, you now want to load all that data on a regular basis to your data warehouse. That's a little bit tough, right? Because there's no export to Parquet, there's no export to CSV, potentially in the format. If there is, you still need to code that in such a way that every day it kind of exports the Delta data, what happened since yesterday, for example. And that type of technology is kind of not really implemented anymore, if it ever was, really, potentially back in the days. So everybody's talking about APIs. Use your API to go get the data. So loading data from apps into any of the three target storage that we're talking about and data storage here requires some type of application development API loading, right? If you're using ClicData, use our connectors. That's an application. It understands the HubSpot or these guys' APIs, and it kind of says, okay, I'm going to store it here, here, here. And it has to paginate because APIs are not notorious for sending a lot of data, et cetera, et cetera. So again, there's some work here. Now, there are exceptions. Some applications allow you to kind of produce these in bulk and send them out, but very few cloud-based apps today do this. Loading from other databases. Now, some of our biggest systems are still potentially in-house or at least in our cloud. And they use MySQL behind the scenes. WordPress uses that as well if you don't want to use their API. Financial system as well. And you still have these databases running your financial, your accounting, your ERP, your CRM system, and you kind of want to bring that data out. You don't want to go through the API. You have a nice database you have access to. What is the fastest way? Well, a lot of these guys have connectors for that, right? So, there's a lot of data warehouse systems that if they don't have connectors, you'd go out and you buy, CData or, Informatic or Talent or something like that. And they'll give you an ETL tool to load it into your data warehouse. With ClicData, again, we have connectors for these. You type your SQL and boom. If for Data Lake, not so much, right? Because Data Lake is looking at storage, and storage are files once again. So what do? Well, you do exports from the database, and most databases have the technology of just bulk export an entire table into a readable text file of sorts, right? Very few have a Parquet writing ability. I don't think I've known of any that have that. A data lake house, again, is a hybrid. So yes, you would have you could use some Informatica, some Talent, or some other proprietary tool to connect the data into your lake house. Okay. That is the loading piece. So here's some tools that you can use to kind of batch integrate. And then we talk about streaming, which is really cool. That is something that is very interesting for us as well as we talk about data lakes. And more importantly, Lakehouses. So tools you can use, obviously Apache Spark, Data Factory, Glue, Data Flow, Google, and again, look at some of the sources that they have in there. Not a lot of sources, but there's third-party tools as well. So these are kind of the equivalent of, if you are a ClicData customer, the equivalent of our connectors and our refresh tools. Okay, streaming ingestion. Now, streaming is actually quite interesting, and this is, we talk about Kafka, not Kafka, Kafka, Kinesis, and a few other things. Now, these are cool because you're no longer really doing batch, large stream. You equate more to sort of an API that sends you, or a data hook, a webhook that sends you data when it's happening. And the data lakehouse is just, bringing that data into the different tables as he needs to. Or he potentially just aggregates all those files into the lake storage portion. So these are kind of tools that are interesting to look at. And again, all this was just about giving you an idea of where we're heading. So once you have this, I'll tell you a bit more about how ClicData and where our direction is on that. The other piece was transform data, right? We talked about transformation. And again, a lot of people talk about ETL versus ELT, whatever. I'm not going to get into that, but it's basically you use kind of the tools either before you actually do the analytics or after you do the storage piece, right? So you kind of need to buy most likely another tool or another module for whatever you're using. But in essence, you have the ability to kind of create columns, clean the data, structure it, etc. And then you load it into the Lakehouse for the analytics, okay? In the case of ELT, you just put the files in the in the data storage and let the Lakehouse go at the files directly, mostly again on Parquet, Delta files, or other type of vertical storage again. And finally, the querying piece, right? The querying and the analytics, and again, you can go with Pythons and things like that. But Databricks has an SQL because they added this Delta Lake thing that allows you to run SQL, and you can run SQL queries on the Lakehouse directly, which is pretty cool as well. Snowflake, Google BigQuery, etc. Databricks again has an ML tool. Azure has an ML tool, but in all cases, you potentially could also set up your own Spark with PySpark, etc., and attack the data directly for ML use cases. All right, so with that kind of overview, and I know it's potentially still semi-confusing. I hope I at least gave you a little bit of an overview of everything, but and that you've learned a little bit. That's probably going to be my last questionnaire, is whether this there was something in here for anybody here. Was there something useful for you or not? I'm going to see if I can ask that right now so that I can see. Can I do question 4? Yeah, so it's a text one, so you have to type, sorry. But if you do have a few seconds to tell me if this is the type of topic that is interesting for us to continue before I get into the ClicData piece, because I just want to get a sense if this type of overview of existing data management, data analytics tools are of interest to some of our customers, some people that watch our webinars. And to see if we're going to do more of this or not. But if you can continue on that, I don't know if I move back to the presentation where if you can continue to answer or not. I hope you can, because I don't want to lose your feedback. Let's see. I'm going to try it anyway, so I don't waste everybody's time. So what does this mean for ClicData? What does this entire thing, how are we going to kind of address the need of those customers that do have large batch files and are interested in using data lake storage type of a facility to store larger files and batch files and keep the history of all those files and so forth. So to look how we do it today, right? Today, you have your apps API, your databases. You can use the data hooks module. You can have like Dropbox somewhere, or Google Drive, or OneDrive, or FTP, and you can have some structured files somewhere. And the only way to get them to the analytics phase, dashboards, reports, to use our data script Python module to do the insights, or to clean the data, is to put them into the data warehouse portion of ClicData. It's the Azure SQL DB. And for that, the data process has to load that data in. Now, that application is needed anyway if you're using apps, APIs, because again, there's a lot of intelligence that goes into getting data a page at a time and so forth. For databases, we have a lot of database connectors built in that you can just get that data as quickly as possible, but there's still a processing a thing. And even with data hooks, we can be listening in for an event to happen in real time. We get the event, we have to parse it and put it into the database. That's how it works today. Anything else that you want to store in the data lake portion of ClicData, which is what we call file storage, you can put structured files and unstructured files, whether it's PowerPoints, images, videos, etc., in your Azure Data Lake or in our file storage, ClicData File Storage. That's where we keep your binary files and large files. But you notice that today we don't have any lines going. We did recently build a data connector from here to here, but it still goes through the data processor. The analytics piece does not tackle directly the data on your file storage at this point in time. Now, what are we going to try to do? Well, we're going to try to do exactly what I just said, which is we want, and forget about this first line here. This is kind of like coming soon. Actually, it's kind of like a little bonus announcement, but we have built this line here, so we can go pull data from here. But more importantly, we can also push data into that as well. And we will hopefully build a way that you can pull data directly from Azure Data Lake. So again, imagine if you have a table, but instead of the table being on your data warehouse, it's your Parquet files, maybe a collection of Parquet files that in total make up a very large table. You would be able to pull that into Dataflow and produce analytics out of that, as well as use that on your Python and SQL data scripts module directly. This is kind of our go-to architecture. We invested in this piece to store other files. We now are going to use that for producing real-time analytics directly from there without having to go to the database, the schema strict database that we have and that we create for every customer we have. But also, we notice this nice little red line here, and why we put that in is because we're also going to build connectors to do things such as image recognition, PDF recognition, and things like that. That's just kind of another outside of this topic, but it's just kind of a go forward view of this. And we're not ending there. This is just kind of our short-term, medium-term vision of how we're going to implement Data Lake. And why we consider ourselves, if you want to go by the full term of the word, Lakehouse, a data warehouse with a data lake. So I guess that makes us a Lakehouse in that sense. The thing we wanted to do as well is abstract the data, irrespective of what that data sits. Right? If you're making a dashboard and you want to pull in a table from your data warehouse, great. But if you want to pull a data that is sitting, it's not a table really, but a data source that is sitting on your data lake on file storage, you should be able to pull that in. So that abstraction of data, we're going to make that happen as well. You will be able to define tables, but that are not actually taking up space on your database, data warehouse. They're actually taking space on your file storage, and with its volume associated with it and so forth, right? And that is important because part of this reason is also the reduction of cost, because storage for us, file storage, is much, much cheaper than a database data warehouse license, right? For us, that means it's cheaper for you as well. And if the performance holds, then you'll get the benefits of high volume storage at a lower cost with a decent performance, right? With that, it's Q&A time. But before I do, and because I always miss doing demos, I just want to show this in case you were not aware. And for that, I'm kind of going to try to screen. So for fear of failed demos, live demos, which is always the thing that makes me want to do webinars and challenge myself, the first thing I wanted to do is show you kind of Parquet files, because I talked a lot about Parquet and there's a big movement around that. But I just wanted to give you some ideas. So here's some sample demos that I've downloaded, and I wanted to show you the CSV equivalent of the Parquet files. And you notice the file difference is when you have low volume, it's actually not that big. But as you go up to higher volume, so here we have 1 million rows of flight data, and with 43 megabytes of CSV and 7.3 megabytes in a Parquet file. So in terms of compression, you can start seeing kind of, again, depending on data. When I show you this data, you'll see, oh yeah, that's why. It's a lot of numbers. Yeah, and numbers compress really nicely. The second thing I want to show you is that we are able to process Parquet files directly into your data warehouse today from file storage or from external systems. So if I drag, the Titanic Parquet file, and hopefully it works. This is kind of the Parquet file, uncompressed, uncolumnar stored, if you will, and it's fairly fast to load, right? Less than a second to load 1,000 rows. It's 1,000 rows. That's not a lot, right? For a Parquet that has a few more, like 1 million rows, and this is where I love getting, kind of start the tingling sensation and saying, oh, is this going to work or not? But you notice here that it's kind of uploaded the file. That's much faster to upload, right? And then it starts uncompressing the Parquet file format and trying to load the data, right? So I think there's about 1 million rows here. So it does its thing and then it finishes up. So it's about 20, let's say 30 seconds to load 1 million rows of data. So quite fast in both cases. I'll get my data in to ClicData quite fast. Again, as you see the data, a lot of numbers, right? Because again, Parquet files are made for this. Now, if I try to open this though, you're not going to be able to see much. It's probably just gibberish. Whereas if I loaded a CSV file, obviously you'll see the data properly as a CSV file. Just wanted to finish with that and kind of show you that you can do some things on ClicData with Parquet files. We haven't added Orc or the other ones, but nonetheless, yeah, you can do a lot of things. So I'm going to try to get back to the presentation and hopefully, hopefully we're good. And I'm just going to check for questions. Do I have any questions? No. All right. I've no questions for now. Okay. Thank you, Excel. Thanks for letting me know. Well, with that, thank you very much. Sorry for the lengthy one. I hope it was useful. If not, maybe next time, just let us know what type of topics you'd be interested in. If you want more ClicData related topics or more generic topics like this. Thank you.